In this lesson, we're going to be looking at adding polynomials. In our last lesson, we were looking and classifying polynomials, so we're going to review that just a little bit. To classify or to name a polynomial, you name it with two names, one based on its degree and one based on the number of terms. So you look at the term with the highest degree, which is 3, so that would make this cubic. There are 3 terms, so that's a trinomial, so that's a cubic trinomial. The next one, the highest degree is 2, so that makes that quadratic. There are 2 terms, so that's a quadratic binomial. If you look at this one, there is an invisible 1 as an exponent, so the highest exponent is 1. That makes it linear. There is 1 term, so that makes it a linear monomial. Here, the highest degree is 4, and there are 4 terms. So that is going to be a quartic for 4. Think of the word quart, 4 quarts in a gallon, 4 quarters in a dollar. Quartic polynomial. If it has over 3 terms, it's just called a polynomial. Now, if you look at this, there are no parentheses. And what we have learned is that when adding terms like this, you look for terms that are alike, like terms, which means the same variable with the same exponent. So in this you have 2 terms that are m cubed. So those are the 2 that you can combine together. And when you combine them together, that would be 17m cubed. There was only 1 term that was m squared, so we just bring it down. You're always looking for like terms. If you look up here, we have 2 terms that are like. We have 2 that are x squares, so we can combine them. And we have 2 terms that are called constants without variables, and we can combine them together. And that would be a negative 4x squared plus 17. Again, if you look for the like terms, we have 2 terms that are s squared, so we can combine those together, and that would be 5s squared plus s. We have 2 terms that are x to the 4th, so we can combine them together. Those are called like terms. We have 2 constants, terms without variables, and we combine those 2 pairs, we get 20z to the 4th minus 6. Now the difference today when adding polynomials, notice that now we have parentheses. So this is a polynomial and this is a polynomial. And they're adding it. When adding it, we're going to learn 2 different methods, either the vertical method or the horizontal method. These are just organizational methods to help you to find like terms that you can combine together. So what I'm going to do first is I'm going to take the first polynomial and write it down. Notice I left a space right here. That is because I'm looking ahead. These are all written in standard form from highest exponent to lowest. I notice that I have a p cubed, I have a p and a constant. Over here I notice I have a p cubed, but I also have a p squared, and I don't have a p squared over here. So this space right here would be for a p squared term, but since I don't have one there, I left that blank. Otherwise, I just took the first polynomial and copy and pasted it down there. Then I take the second polynomial and I'm just going to stack it underneath where the like terms are. So I took the p cubed and I stacked it under the p cubed. I put the p squared underneath the space where there was not a p squared. Here's where the p terms would go, but there's not one in the second term. But notice this is just an organizational way of lining up the like terms, and now you just add down the columns. And when you do that, here you have 6p cubed plus 2p squared minus 2p plus 4. So it's just a way to organize it so that you can combine your like terms. When we look up here again, I notice that I have an n cubed, but I don't have an n cubed over here. I have an n squared here, n squared here. I have an n here, but not over there. So as I'm thinking about that ahead of time, so when I write the first one down, I left space right here where an n term would go, but I don't have one in the first polynomial. And then as I stack the second polynomial underneath it, I stack it according to like terms. So I put the n squared term underneath this one. This one goes underneath a space since there was no n term, and here's the constant. So it's just a way to organize the 2 polynomials, lining up like terms, and then you just add down the columns. So you would have 2n cubed in this column, 3n squared plus 5n minus 2. Another way that you might organize, it's called the horizontal method. It's a way of just, this is a step you might be doing mentally, but I'm going to show you what that mental step would look like by writing it out. So first I see that I have two x squared terms. So I would write out that x squared term right here together. Mentally I'm saying, okay, I'm going to combine 3x squared plus 2x squared. That would be 5x squared. I go to the next term, which is an x term and an x term. So mentally I'm combining a negative 2x plus 6x, and that would be a 4x, positive 4x. And then mentally I'm combining the 5 and the negative 9, which I show right here, which is a negative 4. So this is a way to just kind of organize it horizontally, but you're still looking for like terms. So if I look up here at the two polynomials, I notice that I have two r cubed terms. So I'm going to combine them together. That's 1r cubed plus 1r cubed, which is 2r cubed. I notice that I have two that are r squares. So I can mentally add those together, and that would be a negative 3r squared. Then I have two constants, a negative 7 and a negative 2, and that would be negative 9. So it's just a way to organize looking for like terms that I can combine together. Now, either method can be used. You notice that when I was up here, sometimes I was just circling. Like here I circled the r cubes. Then I might put a square around the r squares. Just some way for you to organize and to look for terms that are alike. Add your like terms, and you have your answer.